Wait, what?
Okay, so for this 11, right? Okay, so you got two arcs, 55 and 5x plus 15. The average of that is going to equal 60. So if I average 55 and 5x plus 15, that's going to be 5x plus 70 over 2 equals 60. Does that make sense at first? Oh, yeah, but I added the 55 though. I already combined it. I got a step ahead.
Yeah, I had what 10?
I had 60 from 51.
Yeah, but you have to add yeah, but there's 5x plus 15 though. There's 5x plus 15, there's 55, and you combine that's 5x plus 70, right? Yeah. So 5x plus 7 over 2 equals 60. You had that or you didn't have that? Oh, cool, cool, okay, good. I just skipped a step. So 5x plus 7 equals 120. 5x equals 50. So x should be 10. You see you got 28? Go, keep going.
Minus 70 equals 190.
Whoa, 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 190. Where you 190 from?
Oh, actually added them.
Okay, there you go. That's it. Okay, you got it. That's just careless mistake happened. Okay. All right. Anything else? Yeah, Colette. Okay, let me see where this number 10 is. Okay, right here. Okay. All right, so for number 10. Okay, so you got two arcs again, right? 4x plus 4 and 12x plus 8. 12x plus 8 is more than 4x plus 4. Subtract it. You get 8x plus 4 up top over 2 equals 50. Move the 2 over. Keep going. You should get 12. Gotta go to both. Yeah, I did. Yeah, 4x plus 4 is subtract. 12x minus 4 is 8x. 8 minus 4 is 4.
Oh.
Yeah, yeah. Yeah, again, that's the thing with this stuff. It gets very what's the word you use? You just have to be careful. There's a lot of like moving parts, which is why I'm foregoing the next section. I'll just show it to you briefly. You'll see. I'll just show you. But this is section 9.6. This is what we had done Tuesday. So, okay, anything else on homework? You good?
I don't even know where we're on.
6. Let's look 6. This number 6. Okay. So that's 65, right? You want to figure out this arc here? So this arc minus 65 over 2 equals 44. So PS is the big arc, QS is the little arc, and you have a tangent and a secant. So when this happens, it's kind of like this case, it's just a little different. These are your two arcs, these are your two arcs. You don't know what this is, what the question mark is. So we'll call it A or whatever. A minus 65 over 2 equals 44. Multiply by 2, add 65, and you get 153. So it's this minus this over 2 equals 44. Just like we saw for all those cases. That's all I did. So, except for when you have two chords, then you add the two arcs. In this, most of the case, you're subtracting. All right. Other questions? I'll go ahead. Yeah, we'll give you the formulas and we'll give you so what I mean I'll double check Mr. Davidson. Actually, you know, I do have actually copies. No, I don't know what he provides. Let me check with him. I'm pretty sure, yeah, like I'm pretty sure it's gonna look like this. So at the end of the notes, we have all this stuff here. I'm pretty sure we have to give a diagram because I think to describe it would be confusing.
I was told by my tutor that we were only going to get the descriptions, like we weren't going to get photos of all the formulas.
I think we are actually.
Okay.
No, I think we have a so
Because I have this formula sheet. It's actually really good.
yes, let me double check with Mr. Davidson. I think it's going to look like this. Because the thing is that no, we're not going to provide all the descriptions. I don't think we're going to do that. But we could say like, yeah, like for example, if you have this situation, here's the formula. For this situation, here's let me double check them. But we have a circles quiz next Tuesday. where we just wanted to see if you can recall these formulas, because that's just a quiz that just goes, actually, I think that goes in the major category, but you do get the formulas for the test and the final, though, that we will provide. That I know for sure. How exactly looks, let me find out from Mr. Davidson. I'm not 100% sure. Okay. Yes. Oh, okay.
Well,
Oh, sorry.
because I also
The homework quiz? Oh, that's easy. I'll take, oh, the circles quiz. All the formulas.
trying to fail us if you're not giving us a formula.
Do good or not? Just kidding, but.
Well, do well.
We.
Well, it's
Yeah,
no. Here's how the quiz. So it's a circles quiz that's next week. So we give you the diagrams, and then you just put the formulas on the diagram. That's what you do.
Oh, so we just.
It's like, okay, if I gave you this, right,
Yeah,
and I call it X and A, and I asked you to write the equation for that, what would you write? X equals what?
A minus B over 2.
No, just this one right here. There's no B.
Oh, A divided by.
There you go. Okay. All right. Okay. What if I gave you this? The center. Here's X and A. What would you say?
X equals A.
Okay. Okay. Anyone but Peter. All right. Okay. If I get A, B, and X.
Two.
So what do you get? What are you guys worried about? What are we worried about? You guys got this. You guys are good. What was that? No, it's no matter. It's just recall. It's I think 7 or 8 points. I don't know. And it goes in major. So yeah, it actually should help you. I mean, if you've been doing practice, which we will do next week, I don't know. I mean, but it's just, I think the reason why we're doing, I think the thinking behind this, and this goes before I start teaching this class, is that if you can recall these forms quickly, or you can be familiar with them, then you don't feel like you're digging through stuff during the test, right?
Yeah.
If you're digging through things for the test, you don't know the formulas, that's gonna be a challenge, right? Now, you may forget something on the day of test, sure. Maybe you might like forget, like, oh, is it minus or plus? And then we give that to you, right? That's okay. So you don't have that anxiety about that. But this is more just like, hey, yeah, I show you a diagram. Okay, what do I do? So I don't think it's that bad.
Have a table diagram. You just have to insert the.
Literally, that's it. It's right here. Yes, I'm just gonna. Okay, I'm gonna flash to you. It looks like this. So a bunch of circles, and you fill it out. That's it.
What?
Okay, that's it.
But what's the writing on the bottom?
A couple few true or false questions. But you guys will be fine. Oh, I could do always, sometimes, never.
What if?
I'm not gonna do that. Mhm.
Yes, and then like a tangent.
They're perpendicular. They're
Oh,
perpendicular.
it's just asking like what the angles are.
Yeah.
Perpendicular.
Yeah, if I said, is the rays perpendicular to a tangent, true or false? There you go. So, yeah, it's you guys will be fine. Okay, anyhow. Okay, I think we're good on homework, guys. Let's move on to the lesson for today. So if you guys go to, okay, here's what I'm punting on. We're punting on this. Okay, so okay, guys, I need you to pay attention so you don't ask, like, I don't answer the same question like 5 times today. All right, so we're skipping 9-7. 9-7 we're going to do away with. So 9-7 is an extension of 9-6. The problem with 9-7 is that a lot of them look like this. Like you have these diagrams again, and you have these chords, and you don't have to draw this, or you'll have like this here. And then what's going to happen is that they're going to label, instead of dealing with the angles, you're dealing with the sides. So they'll call us like A, B, C, and D, or they'll call us like A, B, C, D. And then there's a formula that says, oh, A times B equals C times D, or A times A plus B equals C times C plus D. There's all these funky formulas that go with these. So you're not dealing with angles anymore, or arcs. You're dealing with how the sides cut each other and how they're related. Personally, I think this is really, so you, like these kind of questions, right? Like we haven't done this yet. So like you have to recognize, and we give you the forms, of course, 12 times 6 is 3 times x, or 4 times 12 is 6 times 6 plus x. There's all this stuff. Personally, I think this is really stupid. And that's not, sorry for my poor choice of words. It's really dumb because, first of all, this is never assessed on the SAT. I've been tutoring for the SAT for 25 years. Not once have I ever seen a question like this. It's not covered in the ACT. If they do cover in the ACT, they actually give you the formula It's never reinforced in pre-calculus, never reinforced in algebra 2, never reinforced in calculus. It has no place after this class. So we're going to forego this topic because it's just kind of, it's totally irrelevant. It's totally trivial. So we're not going to do it. This one. So pages 16 and 17, just cross it off. Cross off pages 16 and 17 in your notes.
Yeah, that's so enjoyable.
So we're just not going to cover it. Now, what is relevant is what comes afterwards, coordinate geometry. That does matter because that does play a role in algebra 2. It plays a role in pre-calculus, and actually it has a rhyme and reason to it. It's actually very intuitive. What I just showed you right now was not intuitive. That's why I don't like it. And so that's why, and Mr. Davidson agreed, and we said, yeah, let's just get rid of it. So like in the notes here, there are some things that deal with that. I think at the end, I don't know where, but anyhow. Well, actually, it doesn't cover it, so it's all right. So we're going to jump to coordinate geometry and see how far we get with this today. Okay, so a circle in standard form looks like this: x squared plus y squared equals r squared. And this one looks a little funky: x minus a squared plus y minus a squared is r squared. This looks weird, but when I explain to you why it works the way it does, it makes so much sense. Okay, go ahead. There's 7, yes, right. Yeah. So why does this make sense? Well, if you think about it, what is the definition of a circle in the first place? What's special about a circle? Go ahead, Faith. Yeah, exactly. You have a set of points that are an equal distance away from the center. So if my center is the origin, every dot in the circle, is that equal distance to the center point? Yeah, 100%, right. We know that. So now that we have that established, what if I drew a right triangle here? What if I call my radius r? Well, what should I call the other two sides? Being intuitive about it. Maybe call it, how about x and y? Because x is horizontal, y is vertical, right? Right? X is horizontal, y is vertical, and this is a right triangle. So what famous theorem connects all three of these sides? And where do you see that? Done. That's it.
Oh my
Oh,
gosh.
That's it. That's it.
So
It's not that hard.
simple. Wait, but it's gonna get so hard already.
It's a little bit challenging with the one on the right. Now, the one on the right, here's what you do. And by the way, this is where distance formula comes from too. If you're curious. All right, so this is R. Great. Now, here's the deal. Your center is H comma K. Why we use H and K, it's just a standard for moving things around. That's what a lot of math textbooks use in this and that. So HK is the center. X comma Y is a point on the circle, right? X comma Y is a point on the circle. If you think about it, this corner right here has the same X coordinates as the one up above. You're going straight shot down. So the X coordinate here is just that. The Y coordinate here is the same as the Y coordinate of the center. So that right angle has the coordinates X comma K. Now, if you think about it, that's a crappy looking K. I could do much better.
It's hard to draw with that mouse.
No, but I just like the K. This goes all the way back to grade school. Okay, so think about it. This segment here, the horizontal segment, is that just the difference in the X coordinates? If the X coordinate here is H, and the X coordinate is X, that's just X minus H this time. Look at the vertical wave. The Y coordinate here is Y, it's Y coordinate at the right angle. K, Y minus K. So if I draw it again, if your radius is R, sorry, hypotenuse is R, your horizontal leg is X minus H, your vertical leg is Y minus K. And if you just do Pythagorean theorem, there you go. That's equation of circle. So all you're doing is just taking the difference in the X coordinates of the horizontal leg, which would make sense. Take the difference in the Y coordinates of the vertical leg, that would make sense, it's vertical. Do Pythagorean theorem, and that's equation of circle. It looks kind of complicated with all the letters. It's just Pythagorean theorem. Just find the lengths of the sides and do it. Connor? We'll give it to you regardless, just so you don't worry about it. But just so you understand why it works, it's not something that fell out of the sky. There's a rhyme and reason to it. That's why I like this better than the other section. No. So again, circle radius can be calculated by taking the square root. Yeah, so whatever R squared is on the right side, the square root, that's R, the center is H and K. And you can move this up, down, left, right. Desmos actually does this really nicely. This is actually the one advantage that Desmos has over the TI-4 calculator. If you want to graph a circle, you're gonna have to isolate Y and it gets really nasty with all the radicals and stuff. You just punch it like the way it looks in Desmos, boom, big good circle. And this is on the SAT. This is covered. It's actually covered quite extensively. So I much prefer we do this than 9.7. Click. No, X and Y are general terms. The equation in terms of X and Y. Because X, Y represents all the points of the circle. H of K is going to be a set value that will be given to us. But you have to write the equation in terms of X and Y. You need an equation that has variables in it to represent all the points on the circle. The points of the circle are represented by X and Y. I mean, if I asked you to like give me a particular X coordinate for a certain Y coordinate, sure, then you would plug in whatever the Y coordinate. Let's work on the problems first. That might make more sense. Then that might answer your question. Okay, so let's write this out. This is going to be very, very straightforward. Write the equation of circle, centered at the origin, raised to 4. Easy. That's it. That's all you do. Because if you think about it, if your radius is 4, how far do you go up, down, left, right from the origin? If your radius is 4, you go 4 up, 4 right, 4 left, 4 down. And if you draw a circle, I'll kind of freehand it. It's not going to look great, but it's okay. That's kind of whatever. If you think about it, well, yeah. I mean, of course, the radius is going to be 4. And if I were to do Pythagorean theorem and kind of work it out, you would get something like this here. X squared plus Y squared equals 4 squared. So, what was that?
I think it would be helpful for us to draw them.
I would. That's what we're going to do for number 2. So, number 2, if you look at these numbers here,
They're all square roots.
they're all square. They're all perfect squares. Well, they don't have to be perfect squares, but the radius is going to be the square root of each of those.
So much easier that way. Will it ever not be?
Sometimes.
That's just like.
Would it be like radicals instead?
Yeah, I think most likely we'll keep them as whole numbers. Because the guys are just going to expose this. You're going to see this again in Algebra 2 and Pre-Calculus. Okay, actually, I goofed on part B. Remember we did like translations? You guys remember we did that last semester, the posters, like X minus 1, the quilt stuff? So if you have X minus 1 and Y plus 2, you're going to move 1 right and 2 down. So the center here is 1 comma negative 2. And the center for part C is 0 comma negative 2. So you do want to locate the center first. Should have actually done that part A as well. And why does that make sense? Because your goal is to actually make this 0. So what would make that 0? 1. What would make that 0 negative 2? It would get you back to the original location. Or what would make this 0? Of course, negative 2. Of course, X squared is fine with it. And then you have the radius. So what you do for part B, do you guys see why the center is at 1 negative 2 now for part B? Does that make sense? So the radius is 3. So I have to go 3 up, 3 down, 3 up, 3 right from the center. So if I go 3 above, 3 right, 3 down, 3 left, connect it all. Because if you compare it to the form that we just had up above, H and K, what's in H's position? X minus H, H is 1. Y minus K is negative 2. Or just ask yourself, how's this, what kind of shift, when we did like all the translation stuff last semester? We used -1 went one right, +2 went two left. So that's what we get there. And then the other one is 0, -2. So you go 2 up, 2 down, 2 up, 2 down, 2 left, 2 right. And you get that. And of course, this is just this. So these equations describe these graphs.
Did you draw the triangle inside of them or
No, no, not at all. No. All right. So we're okay with that? All right. So moving on. Let's now talk about 3 and 4. Let's do a description here. So describe the graph of the circle. So what this is going to be, this is going to be a shaded with a dotted boundary. So it's going to look like this. I just felt like drawing the sun. Okay, what am I doing? Okay, like drawing an orange. What's happening? The race is 5, right? Center 0, 0, but it's not an equation in quality. So it's less than, right? So it means that all values of x and y that are less than 0.5, or when you combine them, add it and square it, right? Square it and add it. So why is it dash? You guys remember doing inequalities in middle school?
Yes.
And you had dash, right? Like if it doesn't equal with dash, but it's less than or equal to, it's solid. So that's why I did a dash, the dotted. And then why is it inside? Because you need to pick values of x and y that's outside that inequality. If it's less than, you gotta go lower. If it's greater, it goes outside. Oh, it showed everything outside.
Okay.
Yeah. So yeah, so you think about it. If I plug in 0, 0, that should be included. 1, 0 has got to be included. 0, 1 got to be included.
Wait, if it, the dotted line wouldn't, if it was like less than or equal to, would it be not dotted?
Solid.
Okay.
Because then anything on the boundary counts.
Yeah.
We don't want anything on the boundary to count. That's why we do dotted. Next one's a little kind of a trick question. What do you guys think that one would be? It's something, but it's not much. Even less than that.
Just be a dot.
Where? Middle. What's the middle?
Y across it.
That's it. Yep. Just the origin.
So you would shade that dot though? Or would you
No, just draw a dot. Yeah, that's all. Just so you guys are aware. Okay. Now let's get to the real heart of the matter. The stuff on the next page. All right, so number 5. So I'll do 5. I'll have you guys try the 2 right below. And we'll see how the challenge ones go after that. For 5. Okay. So your center's at 2, 7. Oh, wait. Sorry. Sorry, that the diagram's for part B. My apologies. This is for part B. The diagram. Part A standalone. It's a separate thing. Okay, what's your equation? X minus 2 squared plus, my apologies,
Why confused?
y minus 7 squared equals 1. That's it.
Wait. What's in the circle? Oh, it's part B.
Part B. That's for not for part A. Yeah. Now for part B, but we're cool with part A. For part B, what's your center? And how long is the radius? Count it. Just count it. 2. There we go. I'm trying random numbers today, that's all. Expecting to copy it. Okay. All right, let's slow down a little bit. And no, of course. All right, yeah. Let's start that. So the center is 270. So the way you write this, you always do x minus h squared plus y minus a squared. H and k are the coordinates of the center. And r is on the other side of r squared. So it's x minus 2 squared plus y minus 7 squared equals 1 squared. So that's how you write the equation for part A. For part B, the center is clear at 3, 3. So you do x minus 3 squared plus y minus 2 squared equals 4. Because now we already saw in our conjecture of, oh, if you switch, the center away from the origin, move like up, down, whatever, left, right. H and k represent that movement, and we saw from the Pythagorean theorem that form made sense. X minus a squared plus y minus k squared equals r squared. We saw it made sense, and I know it raises 2 for part B, so that's how I get that. Okay, Connor, go ahead. So no, we're getting an equation to represent the circle. That's all I want. I want you to write the equation of the circle. Nope, never.
What?
So when you're told to write, literally, you're just writing down. There's no work to show. Just write it down. Take the information and put it into the formula. That's it. But how does the formula work? It worked because we did Pythagorean theorem, makes sense. This square plus that square equals that square. If we drew a triangle inside, that's what would make sense. Like for example, actually, let's take a look at the circle in the diagram, right? If I were to draw a right triangle to understand this, right? Okay, we know the radius has a length of 2 because we saw it in other places, right? And then this right here, see, this is x comma y, right? Why am I putting x comma y up there? Because that's going to represent a point in the circle. Some, arbitrary point, I don't know. The horizontal leg is x minus 3. Because whatever x coordinate this is, it's the same x coordinate at the right angle. And that's a 3 clearly. So this length is x minus 3. What's this length here? If this is y, and what's the y coordinate here is 3 still, right? So how long is this? Y minus 3. So think about it. Pythagorean theorem, a squared plus b squared equals c squared. X minus b squared plus y minus b squared equals c squared. That's the fact. Did you guys see that connection? It's all Pythagorean theorem. It's all you're doing. You have a center, which is provided. You have a point, a rand point, which is called xy, and recognize, oh yeah, that's x minus 3. Well, that's y minus 3, x minus 3, and it's Pythagorean theorem. That's all it is. So part C, we probably should do a diagram. That might be a good idea. You're told the endpoints of diameter are at 6 and negative 6. Okay, so this is more mental math. Where's your center? Yeah. And how far do you go up and down? If you're going left, right, 6. When we go up, down 6. Okay, what's my equation?
X squared plus y squared equals 36.
Boom, got it. So you're literally just writing. Like there's not much work to show. Just write it down. Okay, I think I probably should actually give you guys some guidance for 6 as well. And then have to try 7. So for 6, a little bit of work you have to do, a little bit. 17 and 2. Negative 7 and negative 8. Let's connect it all. Yeah, it's not great, but that's okay. Let's draw. And the center is probably somewhere over here, is my guess. Okay, so I kind of lied. There's a little bit of work you have to do. A little bit. Yeah. Okay. But. Not much about them. Four circles and better. That's a better circle. It's not better.
Wait,
I'm rusty. Okay. Well, first of all, I just took the points and plotted. That's all I did so far. Go ahead, you have a question. Speechless. Okay, that's a question.
also speechless.
For number 6. Okay, so I haven't done any work yet. I'm not done yet. I'm just setting it up first. All I did was I plotted the points.
Just to set up.
But I'm setting up 17.2. They have 7.8. I'm just snapping. That's all I'm doing.
Yeah.
What did they give me? They gave me the endpoints by diameter. So I plotted the points and I drew a set between the two. But let's back up a little bit, just so we see step by step again. So if I go step by step. Okay, 17,2 plotted. -7, -8 plotted. Connect the 2 points, done. Draw a circle, done. Put the center, done. Now let's analyze it. That's the next thing we have to do. We have to analyze it because part A is asking for the equation. Well, I need a radius and I need a center. Well, yes and no. You could use this as formula. Yes, you could. Or Pythag, correct. I strongly recommend Pythag. Because this is formula get kind of nasty with the radical. If you think about it, going from -7 to 17. If you want to count it, by all means,
24.
24. I like it.
Bang.
Okay. If you want to count it from here to here, how tall is it? From -8
9?
to
Oh, 10.
10. Okay. And then how do you solve for the hypotenuse?
You do right.
There you go. Yeah. And actually comes out nice and clean. It'll be 25.
Do that.
Well, it's a Pythagorean triple also. I've memorized.
20, 10, 20.
Well, that's 576. No, sorry. No, that's actually. Oh, it's 26. I'm wrong. Oh my gosh. I am sorry, guys. No, I caught myself because 576 plus 100 is not 25 squared. It's 26. Thank you, Kate. It's 26. Okay, so that's 26. Actually, even better. Because what's half of 26?
13.
So that's your radius. There you go.
Oh my god.
See, that's why I like this better because it utilizes some older skills. Now, the center. We did do midpoint last semester. Okay, there's a formula for it. Don't worry about it. We'll give it to you. But do you really need it? I don't think so. If you think about it, -7 and 17 has a length of 24, right? What's half of 24? 12. What's 12 away from 17? Okay. Think about the other side. -18, that's length of 10. Half of 10 is 5. What's 5 away from 2 if you go down? You take 2 away from 5. You take 5 away from 2. -3. There you go. Okay. Now you have that information.
Do that.
X minus 5 squared plus y plus 3 squared equals 13 squared, which is 169. Use a calculator if you need to. And you're using the formula, which is x minus 8 squared plus y minus 8 squared equals 13 squared.
Could you
So-
ever just write 13 squared instead of
That's
169?
fine too. So I like this question a lot because it does utilize a lot of older skills. Personally, I think this is a great final exam question. I love this question. I also like this on the test too. Faith, go ahead. Average coordinates. So if you're going from -7 to 17, you know that's like 24. What's half of 24? 12. Take 12 away from 17. You want to be in the middle,
5.
right? Well, why would call center in the first place? Same here, -8 and 2. It's 10. It's half of 10. 5. Go either 5 up or 5 down. You're gonna be in the center.
Okay.
Ultimately, you'll be in that center point. That's why. Okay, so then the other one, it's a little tricky. It's a good question. I like it, but it's a little tricky. Okay, find the line tangent. Ooh, that's a nice line. Okay, for part B. Okay. Now, you're asked to write the line tangent to the circle at 17,2. Now, this is a little bit extra work. I like special line. Really great. How is the tangent and radius connected to the top of this? The perpendicular, okay. Can I find the radius of the diameter or of the radius? I'm sorry, can I find the slope? Right, sorry, can I find the slope of the radius? Sure. Of course. This is at 5, -3. That's a 17,2. What's the slope of the radius? So rise or run, guys. You guys gotta know this. So going back to algebra 1. How far do you rise and how far do you run? So you go from -3 to 2, and you run from 5 to 12, 17. Go ahead. I think you have to draw it. I'll give you a quarter plane. Okay. Oh, well, no, of course I'll give you a quarter plane. It's not a monster. Of course I would. Okay. So go up 5. 5/12, yeah. So it's 5/12. Sure, yeah. So slope of the race is 5/12. So what's the slope of the tangent? Close. Yeah. So you guys know. -12/5, right? Because you got to do negative, and plus it's a negative slope. Look at it. It looks negative, right? That tangent line. And then the last thing to do, instead of find the y-intercept, I'd much prefer you guys use point slope formula and leave it that way. You don't have to really rearrange it. And this will be provided. We'll provide that for you. So you already know the slope is -12/5. And what's the x coordinate that we're looking at the on the point of the tangency, where the tangent point is?
17.
So x -17, and then y -2, and you can leave it like that. Preferably, I prefer you don't do slope intercept form and you leave it in point slope form. Mainly because it's way more advantageous when you want to do calculus and calculus, which I keep those two classes. I'm like, to keep rewriting slope intercept form is just unnecessary. And it's just fine. And actually, there's some other, which you don't know until much later in these classes. It's advantageous to leave this way.
Okay.
So leave it that way.
You don't even need to simplify.
Don't, please, because
Okay.
mistakes will happen. Don't, and it makes my life hard. Leave it this way. Okay, that's part B. Okay, so yeah, it's a lot going on here. And things that we will need to keep practicing. There will be plenty of practice on this in the review problem set. Just to take a look ahead, because we do need to do the quiz. I might just kind of stop here for today. Homework quiz. Let's do one more, and then we'll do the homework quiz, and then I feel like we have a sense of completion. Then we can do the other problems on Monday. All right, last one. Okay. This one actually will go by pretty fast. Where's my center? I know. Actually, I didn't know. Okay, thanks. Where's my center, guys? Based on what we see in the equation. 4, -2, and that because we get the pattern, right? 4, -2. Awesome. What's your R value? 5, very good. So you go 5 away. That is nice. Okay. Okay, so 1 common negative 6, if I kind of eyeball it, it's kind of like I don't know, over here somewhere. So actually it looks like I did okay with my graph. But how do you verify that 1 negative 6 works? What would you do? I went 5 up, 5 down, 5 left, 5 right. Oh yeah, the way it's spaced out. Yeah, you gotta be mindful how it's spaced out. But how would I verify that 1 negative 6 works? Just plug it in. Yeah. See if it makes sense. No, you have to plug into the equation they gave to us. I mean, it has a center, of course. So that's 9 plus 16. Of course, that makes sense. So yeah. Okay.
I don't get how this graph is like interval.
Every grid is worth 2 units. So that's 1, 2, 3, 4, 5,
Oh.
6. Okay, the last part. Obviously, there's infinite tangent lines, right? There's a bunch of lines I could draw to this. Right? There's a bunch of tangent lines. But if you're asked to name four of them and you want to do this quickly, here's what I do. What would be the equation of those lines? It's going back to algebra 1. Oh god. Okay. What's the y point up top here? Definitely 2.
2.
We'll have
3.
3.
Oh, yeah. 3.
Y equals negative.
Okay. Okay.
Can't see.
Yeah, I know it's not the best grid. Okay, x. X equals probably
9. 9.5, honestly.
the center's yeah, 9, yeah, 9, yeah, 9, 9. And those would be x equals -1.
Nine's kind of like 9.5. It's kind of everything.
But it's gotta be 5 away from the center. So it's gotta be a clean number. Because there's full numbers going on here for this problem.
Yeah.
So yeah, so that's just more in circles. To be continued. We'll do more of this on Monday. We'll do a review. But for the most part, you guys get the idea of circles. So all right, we'll see the homework quiz. We have 10 minutes, so we got plenty of time. This will be fast. Sure, why not? I'll be neat though. Try this out though. I'll be good idea. If you feel like you're stuck, go for it. Strongly recommend you consider drawing triangles for both problems. Strongly recommend the strategy by drawing triangles. Right. And then Sabine and Zoe, you just could do the other quiz next week. So I have another version of it.